Welcome to section 2-6, solving literal equations for a variable. I'm going to start with a few vocabulary, pretty similar to what we often do. Here we go. You should be on page 28 of your notes, and there's a nice space there for you to write the definition for the word formula. A formula is an equation that states a rule for a relationship among quantities. So it's something that we use all the time. We know that relationship, fits with it all the time. Couple quick examples of formulas, something like area of a circle equals pi times radius squared, right? Very famous formula, E equals mc squared. Right? We know all kinds of formulas for math, for science, right? And we use those a lot when we don't want to have to figure everything out every single time of how the variables are related. Right? If we look at a formula like d equals r times t, the distance formula, distance equals rate times time, the d right now is isolated. And isolated is just another way of saying it's all by itself. Okay? And we can really isolate any variable in the equation by using inverse operations. So depending on what we're going to do with that formula, sometimes it's not really very convenient to leave it in the original format. We might want to solve for a different variable. So maybe we've done a science experiment where we need to calculate a whole bunch of times based on the distance and the rates. Well, rather than having to go through and divide every single time, like set up my equation and divide every single time, I could just solve the equation for t instead. And I just do that by using inverse operations. So if d equals r times t, and I want to get t all by itself, and we'll talk more about how to do this in a second, right? Then I want to get rid of the r, so I'm going to divide both sides by r, right? And now I have t equals, let's rewrite it down here where we actually have space. Oh no. Equals, come on board, equals d over r. See if I can write on the screen again. There we go. Equals d over r. On page 28, you have room for the steps for solving for a variable. You're going to copy these down. Remember, if you don't have time, you can go ahead and pause the video. Okay. Step 1, right? We locate the variable we're asked to solve for in the variable. I like to underline it or circle it, do something so you know what that variable is. Then you identify the operations that are done to that variable and the order that they're done in. So it's multiplied by something and then something's added to it, whatever it happens to be. And then we use inverse operations to undo the operations we can see and to get the variable all by itself. Really, this shows me how well you understand the process of solving an equation, because there's no numbers or any, way of using mental math to figure it out. You have to actually know how to work backwards through the steps of the equation solving. Okay, there's no sort of, using mental math to figure it out without being able to actually show what you're doing. So here's that distance equals rate times time formula again, right? The first thing the problem says, actually I think this is kind of what we did earlier, is to solve the formula d equals r times t for t. And then we're going to go ahead and find the time in hours that it would take Scott to travel 26.2 miles if his average speed was 18 miles per hour. So we take our formula here and we want to get t all by itself. Notice it's in purple, so you can easily see it, right? So to do that, we want to undo the multiplication, right? We get our r over r is a fancy form of 1. So distance over rate equals time. And now we can go ahead and plug in the information from the problem. We know he's gone 26.2 miles, a marathon distance, and right, he's going to go 18 miles per hour. Okay. Now that is not a very nice math problem to do in my head, so let's pull up our calculator and clear it out. And we get 26.2 divided by 18 equals 1.455555 forever, and it has asked us to round it to the nearest hundredth, so 1.46 miles, right, per hour. No, 1.46 hours. We're looking for his time, right? So he could run the marathon in a very speedy 1.46 hours. Okay. I think he must be riding a bike. I don't think he could be running. That example, by the way, I did want you to write that down. You might need to go back because I didn't say that. So go back, write it down. Where should you write it down? You should write that one down in the physical science box at the bottom of the page, including the number part. So rearrange it, solve it for t, and then fill the numbers in also. So if you need to stop, rewind, go ahead and do that. We're going to move on to a geometry example, which also goes in the box at the bottom of page 28. Okay. And we're looking now at the formula for the area of a triangle, 1/2 base times height. B is the length of the base, and h is the height, and we're going to solve for h. Okay? So I'm going to circle it, and I'm going to think about what happened to that h. Right? Well, it got multiplied by 1/2, and it got multiplied by b. Right? So the first thing I'm going to do is I'm going to get rid of the 1/2. It doesn't really make any difference what order I actually do. And anytime I want to get rid of a fraction, right, I go ahead and I multiply by its reciprocal, which is just 2. So now the 1/2 and the 2 over 1 cancel each other out. And I have 2 times a equals b times h. And remember, h is what I'm trying to get all by itself. So then I'm going to divide both sides by b. And that's all I have to do. So 2 times the area divided by the base gives us the height of the triangle. Of course, dividing by a fraction is the same as multiplying by its reciprocal. Instead of having an earth science example, we're going to put in this random example, so you can cross out earth science and write random typing example in its place. Okay. And I like this formula just because it is really random, but kind of handy at the same time. So if we want to find your typing speed, we take how many words you can type, right, and in a certain amount of time, which we give in m minutes, and we subtract out 10 times your number of errors, right? And so words minus 10 times your number of errors, and we divide that by how long you typed. But now we're going to try and solve for e. Okay. So the first thing I noticed is we have this big fraction, right? So everything up top is divided by m. I want that m to go away, just like when I had things divided by 4 or 5, right? So I'm going to multiply everything by m, right? And now these m's on the right side cancel out. And I have m times s equals w minus 10e. And then just like in any other two-step equation, I always want to deal with the variable that's not attached, right, to what I'm solving for. So I'm going to subtract w from each side. Now they're not like terms, so they don't combine. You just get ms minus w equals, zip zap, negative 10e. And now I can divide both sides by negative 10. And there is my equation solved for e. So if I want to know how many errors you made, I can take how long you typed, multiply it by your typing speed, subtract the number of words you typed, okay, and then divide it by negative 10. It's complicated. Okay. Remember, the trick here is that you have to pay attention to what variable you're solving for and the operations that were done to it, and then you have to undo each of them one at a time. It is a little bit trickier than it looks at first. Formulas are types of literal equations, and a literal equation just means that it's pretty much all variables, 2 or more variables, rather than numbers so much, right? And same thing, when we want to solve for one of the variables, we're going to use inverse operations. We end up doing this a lot when we start graphing equations and things like that, because when we graph equations, we often want to have the equation solved for y. So if I had something like, 2x plus 3y equals 10, right? I often don't want my equation like that. I want it solved for y. So then I use this same process, right? I'm going to take two x's away from each side, right? And now I have 3y's equal 10 minus 2x. And then I'm going to get y all by itself by dividing by 3. So we end up doing this a lot. In just a couple months here in algebra, we'll be going over this again because this is so important. Let's try a few of these, though, that don't have anything to do with specific formulas, just random collections of variables. And I want you to put these down at the bottom of the page below that box. Okay, if you don't have room there, find someplace, I don't know, up by the key concepts words, right? You should have room there. So let's start out with a kind of a basic one. X plus y equals 15, and we're solving that for x. So the only thing over there with the x is the y, and it's added, so we're just going to subtract it, right? And 15 and negative y are not like terms, so we just leave it as is, 15 minus y, or you can write it as x equals negative y plus 15. Both of those would be fine. P times q equals x for q. That's a pretty easy one-step one, right? We want to get q all by itself, so we're just going to divide both sides by p. Q equals x over p. All right, very last one. 5 minus b equals 2 times t. We're looking to get t all by itself. Well, it is already almost all by itself. The only thing I need to do is divide by 2. And I'm done. 5 minus b all over 2 equals t. And that's it. This is one of those things, though, that when you come in tomorrow and we start doing them over and over again, it gets kind of confusing. It is trickier than it sounds to get that variable all by itself and follow through all of those opposite operations, inverse operations. So be ready for it to maybe be a little bit trickier than it seems right now. Have a good night.